Software Development Security Rocket Ship Group. So for this presentation, we're going to start with table of contents. Firstly, we're going to introduce system development controls. Then we're going to see application programming interfaces. After that, we're going to see establishing databases and data warehousing. Then storing data and information. And finally, understanding knowledge-based systems. To start, a little phrase from the chapter 20 that I really liked. Organizations use custom developed software to achieve unique business objectives. The software could present several vulnerabilities, and it's vital to introduce security controls to the system development cycle to ensure protection against the vulnerabilities. Since this is a security course, so it's interesting, this chapter is focused on the security implemented in the software development processes. Firstly, we're going to introducing system development controls. A lot of programmers prefer to write code in high-level languages such as Python, C++, Ruby, R, Java, Visual Basic, and others. Object-oriented programming, very well known in our career. C++ and Java and other modern programming languages support object-oriented programming. Every object in the object-oriented programming model has methods that correspond to specific actions. Objects can be subclasses of other objects and also inherit methods from their parent class. And from a security point of view, object-oriented programming provides a black box approach to abstraction. The users need to know the details of an object's interface, but they don't need to know the inner workings of the object to use it. So from a security point of view, it's very good. Then assurance. To ensure that security control mechanisms built into a new application properly implement the security policy throughout the lifecycle of the system. Administrators use assurance procedures. Assurance procedures are simply formalized processes by which is built into the lifecycle of a system in it. Avoiding and mitigating system failure. You should plan for when a development team encounters a failure, ensuring that the system will respond appropriately to that failure. Input validation. Input validation verifies that the values provided by user match the programmer's expectation before allowing further processing. Input validation should always occur on the server side of the transaction. Any code sent to the user's browser is subject to manipulation by the users and is therefore easily circumvented. In this part of the presentation, we're gonna see what we can do to avoid and mitigate system failures. So yeah, input validation is an example. Then authentication and session management. One of the core security tasks facing developers is ensuring that those users are properly authenticated, that they perform only authorized actions, and their session is securely tracked from start to finish. The level of authentication required by an application should be tied directly to the level of sensitivity of that application. It is generally more secure to make use of an existing hardened authentication system than to try and develop an authentication system for a specific application. Error handling. In-depth error messages are crucial for debugging code, and it makes it easier for technical staff to diagnose problems experienced by users. But there's also a big vulnerability in these messages. They could include sensitive information to attackers and expose it, like for example database tables, addresses of internal servers, and others. So the developers should disable the detailed error messages or on any servers and applications that are publicly accessible, so that they cannot be accessed by attackers. Logging. Applications should be configured to send detailed logging of errors and other security events to a centralized log repository. OWSAP suggests the following: input validation failures, authentication attempts, Access control failures, tampering attempts, use of invalid or expired session tokens, exceptions raised by the operating system or applications, use of administrative privileges, transport layer security failures, and cryptographic errors. Fail secure and fail open. So, failures are unpredictable. Programmers should design into the code a general sense of how to respond to and how to handle these failures. Firstly, the fail secure failure state puts the system into a high level of security until an administration can diagnose the problem and restore the system to a normal operation. Then there's fail open. When it's in a fail open state, it allows users to bypass failed security controls, erring on the side of permissiveness. Now, moving forward, systems development cycle. Firstly, conceptual definition, then function. This is the development cycle of a system. First, there's the conceptual definition, then the functional requirement determination, then the control specifications development, then the design review, fifth, code review walkthrough, sixth, user acceptance testing, seventh, maintenance and change management. Conceptual definition. This is the first step of the development cycle life cycle. The conceptual definition creates a basic concept statement for all the system. It is a simple statement agreed on by all the interested stakeholders that state the purpose of the project as well as the general system requirements so that everybody can be on board and on the same page. Functional requirements determination. Specific system functionalities are listed here, and developers begin to think about how the parts of the system should interoperate to meet their functional requirements. The deliverable from this phase of development is a functional requirements document that lists the specific system requirements. Three major characteristics of functional requirements are inputs, behaviors, and outputs. Then, control specifications development. It is important to analyze the system from a number of security perspectives. First, adequate access controls must be designed into every system to ensure that only authorized users are allowed to access the system and that they are not permitted to exceed their level of authorization. Secondly, the system must maintain the confidentiality of vital data through the use of appropriate encryption and data protection technologies. Then, the system should provide both an audit trail to enforce individual accountability and also a detective mechanism for illegitimate activity. And finally, depending on the criticality of the system, availability and fault tolerance issues should be addressed as corrective actions. Design review. In this lengthy process, the designers determine exactly how the various parts of the system will interoperate and how the modular system structure will be laid out. User acceptance testing. Most organizations perform the initial system tests using development personnel to seek out any obvious errors. As the testing progresses, developers and actual users validate the system against predefined scenarios that the model common and unusual user activities. Maintenance and change management. Once a system is operational, a variety of maintenance tasks are necessary to ensure continued operation in the face of changing operational, data processing, storage, and environmental requirements.
Life cycle models. In the 70s and 80s, pioneers like Winston Royce and Barry Boehm proposed several software development life cycle models to help guide the practice toward formalized process. In 1991, the Software Engineering Institute introduced the Capability Maturity Model, which described the process that organizations undertake as they move toward incorporating solid engineering principles into their software development processes. We'll take a look at the work produced by these studies. The Waterfall Model. It was developed by Winston Royce. The traditional water model has 7 stages of development. As each stage is completed, the project moves into the next phase. As illustrated by the backwards arrows, the modern waterfall model does allow development to return to previous phase to correct defects discovered during the subsequent phase. One of the major criticisms of this model is that it allows the developers to step back only one phase in the process. The spiral model. Barry Boham proposed an alternative lifecycle model that allows for multiple iterations of a waterfall-style process. Each loop of the spiral results in the development of a new system prototype. Theoretically, system developers will apply the entire waterfall process to the development of each prototype, thereby incrementally working toward a mature system that incorporates all the functionality requirements in a fully validated fashion. Bohm's spiral model provides a solution to the major criticisms of the waterfall model. It allows developers to return to the planning stages as changing technical demands and customer requirements necessitate the evolution of a system. Agile software development. As we can see, there is a document titled Manifesto for Agile Software Development that states the core philosophy of the Agile approach. The Agile development approach is quickly gaining momentum in the software community as many variants, including the Scrum, Agile Unified Process, the Dynamic Systems Development Model, and Extreme Programming. Software Capability Maturity Model. It is intended to help software organizations improve the maturity and quality of their software processes by implementing an evolutionary path from ad hoc, chaotic process to mature, disciplined software processes. Describes the principles and practices underlying software process maturity. It is intended to help software organizations improve the maturity and quality of their software process by implementing an evolutionary path from ad hoc, chaotic process to mature, disciplined software process. The ideal model. The ideal model is the software engineering ideal model. The Software Engineering Institute also developed the ideal model for software development, which implements many of the software capability maturity model attributes. The ideal model has 5 phases, which are initiating, diagnosing, establishing, acting, and learning. Here we have 2 charts that are Gantt and PERT. Gantt chart is a type of bar chart that shows the interrelationships over time between projects and schedules. Program Evaluation Review Technique. PERT is a project scheduling tool used to judge the size of a software product in the development and calculate PERT. It is used to calculate the standard deviation for risk assessment, and is also used to direct improvements to project management and software coding in order to produce more efficient software. The word DevOps is a combination of software development and operations, symbolizing that the functions must merge and cooperate to meet business requirements. And the DevOps model is closely aligned with the Agile development approach and aims to dramatically decrease the time required to develop, test, and deploy software changes.
Application Programming Interfaces. Application Programming Interface Implementation. Modern web apps are more complex than before. So, implementing APIs allow organizations to interact with the underlying service through function calls, but it has its risks, and that's where authentication requirements come in. Software testing. Every organization should thoroughly test software before distributing it, and the best time for it is when the modules are being designed. There are various types of testing. The first one is black box testing, which examines internal logical structure through reading line by line. The second is white box testing, which tests consist in testing from a user perspective without accessing the internal code. The third one is gray box testing, which mixes black box and white box, analyzing inputs and outputs. Then we have static testing, which evaluates the security without running it, by analyzing the source code or compiled application. And the last one is dynamic testing, which evaluates security in a runtime environment, like scanning for cross-site scripting and SQL injections. Code repositories. Code repositories provide several important functions supporting these collaborations. Primarily, they act as a central storage point for developers to place their source code. Code repositories are wonderful collaborative tools that facilitate software development, but they also have security risks of their own. Service level agreements. SLAs ensure that organizations providing services to internal and/or external customers maintain an appropriate level of service agreed on by both the service provider and the vendor. Some issues they address are system uptime, maximum consecutive downtime, peak load, average load, responsibility for diagnostics, and failover time. Software acquisitions. Most of the software used by enterprises is not developed internally, but purchased from vendors. Some of this software is purchased to run on servers managed by the organization. Other software is purchased and delivered over the internet through web browsers in a software-as-a-service approach. In either case, security is a matter of concern. Security professionals must understand the proper configuration to meet security objectives. Topic number 3. Establishing databases and data warehousing. Databases and data warehousing. Almost every modern organization maintains some sort of database that contains information critical to operation. Because of the growing reliance on database systems, information security professionals must ensure that adequate security controls exist to protect them against unauthorized access, tampering, or destruction of data. Database Management System Architecture. The vast majority of contemporary systems implement a technology known as relational database management systems. SQL is an example of this. They consist of hierarchical and distributed databases, which in this case a hierarchical data model combines records and fields that are related in a logical tree structure. This results in a one-to-many data model, which where each node may have 0, 1, or many children but only one parent. The user perceives the database as a single entity, even though it consists of numerous parts interconnected over a network. Each field can have numerous children as well as numerous parents. Thus, the data mapping relationship for distributed databases is many-to-many. We also have relational databases, which consist of flat two-dimensional tables made up of rows and columns. In fact, each table looks similar to a spreadsheet file, like Microsoft Office Excel. The row and column structure provides for one-to-one data mapping relationships. Each table contains a number of attributes or fields. Each attribute corresponds to a column in the table. The table is also known as relation. For relational databases, records are identified with keys, which are a subset of the fields of a table and are used to uniquely identify records. There are three main types. The first one is a candidate key, which is a subset of attributes that can be used to uniquely identify any record in a table. The second one is a primary key, which is the one attribute that is selected from the set of candidate keys for a table to be used to uniquely identify the records in a table. And the third one is the foreign key, which is used to enforce relationships between two tables, which is also known as referential integrity. The foreign key of one table is the primary key of another one.
Database transactions. Transactions are really important because it contains operations that are key for many systems. So relational databases always supports explicit and implicit the use of transactions in order to store the integrity of the database. A transaction is a special group of instructions that will succeed or fail as a group. This is an example of a transaction in SQL code. The key characteristic of this transaction is that it has to occur, it has to be committed, or it would fail because it has to maintain the integrity of the database. For example, if this was a bank database and you want to withdraw some money and only get the balance out, it will be very difficult and a breach of security if only one part of the transaction occurs. But the key characteristic of the transaction is that it would have to succeed as a group or fail as a group. Some of the transactions characteristics are with the ACID model, which means that atomicity, consistency, isolation, and durability. For atomicity, we must say that there are all or nothing, which means that the transaction will fail if a part of the transaction doesn't execute correctly, or it will succeed if all the instructions were stored correctly. The consistency is that all transactions must begin operating in an environment that is consistent with all database rules. For example, that all records that have a unique key, a unique primary key, for example, all the rules that are defined by the database. Then we have isolation, which isolation is a transaction must operate separately from each other, which means that, for example, with the withdrawal of money, everyone can withdraw money whenever they want, and it do not have to wait for other people to finish their transaction. They can occur separately from each other. Durability, which means that once they are committed to the database, they must be preserved, and the logs or etc. Okay. Security for multi-level databases. Many organizations now use different schemes to enforce security alongside different classification of data, and they restrict and access control based on those security labels assigned. Um, Many organizations use data classification schemes to enforce access control restrictions based on security labels assigned to data objects and individual users. We must say that one of the main security that should have the database is concurrency, which is a preventive security mechanism that endeavors to make certain that the information stored on the database is always correct. This can be do with many ways, but it's like ensuring that your data is useful data and not corrupt data or data that will mislead many things. The consequence of lack concurrency is that loss updates may occur when two different processes make updates to a database and are unaware of each other's activity. Dirty reads occurs when they record a transaction that was not successfully committed, like we talked before. Then we have other security mechanisms that can be used by the DBMS. We have semantic integrity that ensures that user actions don't violate any structural rules. Also, we have control granularity, which means that they manage the objects in a granular way to have control between the access based on the context or payload of the object being accessed. Self-suppression is another kind of control granularity. Self-suppression is the concept of hiding individual databases fields or cells or imposing more security restrictions on them. And there are many others, like police instantiation. Open database connectivity. So an ODBC is a database feature that allows applications to communicate with different types of database. Now there are a lot of organizations that have multiple data drivers, and is a really good security practice to have a manager between all those data drivers, that you don't have to instance or interact between all the data drivers. So now, as database technology evolves, many organizations are not using relational databases like SQL, and now they're using NoSQL databases, which are databases that are not in the relational model. Some of these databases are the key value stores. Like it's a very simple database, key value stores, the graph database, which stores data in a graph format, and the document stores like Mongo, which stores information in a JSON or JavaScript object notation. Storing data and information, which nowadays all the systems they gain power of data, so it's important to know some of the types of storage that they can have. The primary or real memory consists of memory resources available directly from the CPU. The secondary storage is the more inexpensive non-volatile storage, which is available for a long-term use. Then we have the virtual memory that allows the system to simulate additional primary memory resources through the use of secondary storage. The virtual storage also allows the system to simulate a secondary storage resources through the primary storage. Then we have the random access storage and the sequential access storage that allows the system to request context from any point within the media, like the RAM or hard drive, for example. Then we have the volatile and non-volatile storage, which the difference between them is that one loses its content when they are removed from a power flash and the other don't. Then we have some storage threads that always are a threat for this type of storage, which the principal threat that it has is the illegitimate access to a storage resource when it is. So the first threat, the legitimate access a is a principal threat to all this storage mm, for all the type of storages. And then we have like covert channel attacks, which allow the transmissions of sensitive data between classification levels through the direct and indirect manipulation of shared storage media. Then we have understanding knowledge-based systems, which knowledge-based systems that are based on data, and they do actions, take decisions with that data. We got expert systems, which are like accumulate knowledge of experts of a particular subject and apply this consistent knowledge into decisions and actions. Then we have one characteristic of this expert system is that they're not infallible because they are good as the data that they are that they have, for example. Then we have machine learning, which are techniques and used to have analytic capabilities to develop knowledge from data sets without the direct application of human insight. There are two machine learning techniques that are supervised learning techniques and unsupervised learning techniques. Then we have the neural networks, which are chains of computational units that are used in attempt to imitate a biological reasoning process of the human mind. And security applications are that these knowledge-based analytic techniques are great applications in the field of security because they can get data from the security field and take decisions from that.